Hello runners. So again here is teacher Asaf. As I promised, we will be working out some division questions. There is a question here I want us to do together, and this question is in the topic differentiation, and we are going to answer this question. The displacement h meters of a moving particle along a straight line after t seconds is given by h cubic over 3 minus 3t squared plus 9. The first question, A Roman 1, determine the value of t when the particle is momentarily at rest. So we have been told to determine the value of t when the particle is at rest. So what we need to understand is that when the particle is at rest, the velocity, that is dx over dt, is equal to 0. So at rest, or when the particle is momentarily at rest, the velocity is equal to 0. So we will take our function here, h is equal to t cubic over 3 minus 3t squared plus 9, and determine its derivative. So the derivative will be dx over dt is equal to, so we are going to differentiate this. We will take the power 3 and multiply it with a constant, that is a third. So it is going to be t squared minus, so for us to differentiate 3t squared, we will multiply 3 times 2, which is 6t plus 60, minus 60, and that is our derivative. So having that as our derivative, we are going to determine now the value of t when the particle is momentarily at rest, and we are aware that when the particle is at rest, the velocity is 0. So we are going to equate the two expressions and have t squared minus 6t is equal to 0. And by having that, we are going to factorize this. Is a quadratic expression, or is a quadratic equation. We'll have t into brackets t minus 6 is equal to 0. So we will have t is equal to 0, or t minus 6 is equal to 0. So having that, our value of t will either be 0 seconds or t is equal to 6. So those are our values of t when the particle is momentarily at rest. You can check out my previous video that I taught concerning how to differentiate, so that you will understand what has happened to this function for it to become t squared minus 6t. So we have already determined the value of t when the particle is momentarily at rest. T is 0 and t is 6. So by doing that, you will get your 3 marks. So let's proceed to question Roman 2. The question 2 reads, the values of the displacement h meters by the time the particle comes to rest. So we have been asked the displacement, and we are quite aware that the equation for displacement is h is equal to t cubic over 3 minus 3t squared plus 9. So we will take this equation as it is. H is equal to t cubic over 3 minus 3t squared plus 9, and we have been told to find the values of the displacement h. So the values of the displacement h at rest, and when it is at rest, t is 0 and t is 6. So we will find our displacement when t is 0, and we will have h is equal to 0 cubic over 3 minus 3. We replace t with 0, 0 squared plus 9. We will have our h as 0 divided by 3 is equal to a 0. Any number multiplied by a 0 is a 0 plus 9. So our h is going to be 9 meters. So having that as 9 meters, don't forget that we had two values of x, we had two values of t, sorry, and in our two values of t, we are going to find the second one. X is t cubic over 3 minus 3t squared plus 9 when our t is 6. When our t is 6. So our x will be 6 cubic. 6 cubic is equal to 216. 216 divided by 3 minus 6 squared is 36. 36 multiplied by 3 will give us 108 plus 9. So after solving that, we will get our x as 216 divided by 3. 216 divided by 3, we will have 72 minus 108 plus 9, and our displacement will be 72 minus 108 plus 9. We will have our displacement as negative 27 meters. So that is the value of the displacement 8 meters when the particle is at rest. Then we will proceed to our third question. Our third question reads, determine the value of t when the velocity of the particle is negative 5 meters per second. Determine the value of t when the velocity of the particle is negative 5 meters per second. So we are going to take the equation of velocity, and our equation of velocity was dx over dt is equal to t squared minus 6t, and we have already been told our velocity is equal to negative 5 meters per second. So our dx over our dt is equal to negative 5. So for us to determine the value of t when the velocity of the particle is negative 5, we are going to equate the two expression and have t squared minus 6t is equal to negative 5. We will take this to the other side of the equal sign and have t squared minus 6t plus 5 is equal to 0. So it has formed a quadratic equation, and in this quadratic equation we are going to solve this quadratic equation using, we can use factorization, we can use any other formula to determine the value of t. In my previous video, there is a video I've specifically made on how to solve quadratic equation using factorization, and by following that question or that video, you can be able to understand on how we determine the value of t. So we will quickly determine our value of t. Minus 6t plus 5 is equal to a 0, and by having that, we are going to find the product. The product of our function is 5, and our sum is equal to negative 6. Therefore, two factors that we can use to get 5 and negative 6 as sum is negative 5 and negative 1. So negative 5 times negative 1 is 5. Negative 5 plus negative 1 is negative 6. So we will have t squared minus 5t minus t plus 5 is equal to 0. By having this, we will factorize and have t into brackets t minus 5 minus 1 t minus 5 is equal to a 0. So by having that, we will have t minus 1 t minus 5 is equal to a 0. So this one simply means t minus 1 is equal to 0, or t minus 5 is equal to 0. So t is equal to 1 or t is equal to 5. So we have already determined the value of t when the velocity is negative 5 meters per second. So let's continue with our last part. The question reads, determine the acceleration of the particle at t is 2. So the equation for velocity is t squared minus 6t. For us to find the equation of acceleration, we need to differentiate velocity with respect to time. And how do we go about that? We will take dv over dt is equal to 2t minus 6. So this is the equation for acceleration. So acceleration is equal to 2t minus 6. So having this as the equation for acceleration, we can now be able to find the acceleration of the particle when t is 2, and that will be a is equal to 2t minus 6, where t is 2. And by substituting the values, we can be able to determine the value of a. A is equal to 2 multiplied by 2 minus 6, and our a will be 2 times 2 is 4. 4 minus 6, our acceleration will be negative 2 meter per second squared. By doing that question, you'll get your 2 marks. So that is how we solve application of differentiation in calculating velocity and acceleration. And ensure you hit the subscribe button. Ensure you also turn the notification bell so that each and every time I upload a new video, you will always be updated. So that is how we approach this particular concept. This is a section B question, mostly assessed in paper 1 KCSE, and I believe as we continue, you will continue becoming better and better in mathematics. I wish you all the best. Ensure you like my video. That is like telling me thank you, and I'm always motivated to help you learn. Thank you so much. Have a blessed day.